What I learned about structs and classes in Swift. In Swift, structs allow us to create custom data types that can hold variables and functions together. Here's an example where I make a struct for an anime. Swift struct anime, let title, string, let studio, string, let year, int func print summary, title, year, by studio. In this example, I have an anime struct with three constants, title, studio, and year. There's also a function that prints a summary of the anime. Notice how the struct name starts with a capital A. That's a convention in Swift, just like how we use lowercase for properties and methods like title and print summary. Now let's create some anime instances. Swift let Naruto equals anime Naruto, studio Pierrot, year 2002, id. Let Demon Slayer equals anal Demon Slayer, studio UFO table, year 2019. Naruto.printSummary. L'Arche prints Naruto 2002 by Pierrot, Demon Slayer.printSummary, prints Demon Slayer 2019 by UFO table. Both Naruto and Demon Slayer are instances of the anime struct. Even though they are based on the same struct, they store their own data. When I call print summary, it uses the values from each individual anime. Attached are structs and mutability. With structs, Swift treats them as value types. This means that if I create an instance of a struct using let, I can't modify any of its properties. Let's see this in action with a character struct. Swift struct character, let name, string, var power level int, mutating func train, power level plus equals 10, print name, trained and increased power to power level. Var Goku equals character name Goku, power level 9000. Goku.train, Goku trained and increased power to 9010. Here, Goku's power level is increased using the train function. Notice how I use the mutating keyword? That tells Swift that the function is allowed to modify the struct. If I had declared Goku as a constant using let, I wouldn't be able to call train because Swift doesn't allow changes to constant structs. Classes and constants. Unlike structs, classes behave differently with constants. If I create a constant class, I can still change its variable properties. Let's use an example with a class for a hero. Swift class hero var name equals Saitama, let Saitama equals hero, Saitama.name equals Genos. This works even though Saitama is a constant. Even though Saitama is declared as a constant using let, I can still change the name property to Genos. That's because classes are reference types. Swift only makes the reference constant, but the data inside can still change. If I want to prevent the name from being changed, I could declare it as let inside the class. Swift class hero, let name equals Saitama. Changing the name would now give an error. Computed properties. I can also use computed properties in Swift, which calculate their value dynamically. For example, let's create a character struct where the character has an allocated power level, but we calculate the remaining power after battles. Swift struct character, let name string var total power equals 100, var power used equals 0, var remaining power int total power used. Now, instead of keeping track of remaining power manually, it is calculated automatically based on how much power has been used. I can then use it like a regular property. Swift var Naruto equals character, name, Naruto Uzumaki, Naruto.power used plus equals 30, print Naruto.remaining power, slash prints 70. Here, remaining power is computed every time I access it based on total power and power used. Property observers in Swift, I can add property observers that run some code when a property changes. For example, if I have a struct to track a hero's score in a battle, Swift struct battle, var score equals 0, did set print the score is now score, var battle equals battle, battle.score equals 10, prints the score is now 10. With the did set property observer, every time the score changes, Swift runs the code inside it and prints the new score. This way I don't have to manually print the score every time it changes. Swift handles it for me. Initializers. Swift automatically creates an initializer for structs based on their properties, but I can also create my own custom initializer. For example, let's say I want to create a villain struct and give it a random power level when created. Swift struct villain. Let name string let power level int init name string name equals name self power level equals random in 1.1000 val. Now every time I create a villain, it gets a random power level. Swift let Madara equals villain Madara Uchiha, print Madara.power level so that prints a random power level. Swift generates an initializer by default, but by writing my own, I can customize how instances of my struct are created.